Hi friends, now we'll discuss kinetics of particles, where in kinetics we'll analyze motion of bodies considering masses of the particles and the forces which causes the motion. In kinetics of particles, third part we'll discuss, which is based on impulse, momentum, collision between elastic bodies, in that one impact. In impulse momentum, when any two bodies having some masses, say m1 and m2, collides with each other, then exactly what happens? If we'll assume this one is one body, say this one is a bat, and say this one is other body, which one is nothing but say ball. Now this one is a body 1, say ball. This one is a next body, say bat. Say this one body is 1, this body is 2. This ball means body 1 having some mass m1. This bat means body 2 having some mass m2. Now if this ball moves in rightward direction and then this ball strikes the bat. Now when this ball strikes with the bat, what forces are developed or what reactions are developed, that one we'll see. When this ball strikes with the ball, what diagram I am drawing, this one is when this ball is in contact with the bat. When ball strikes, then ball rebounds. When ball rebounds, this bat or this batsman also experience some jerk which opposes or which acts in opposite direction. That means when this ball strikes with the bat, some force is exerted by ball on the bat. This is a force exerted by ball on the bat, say in the rightward direction. Similar force, same amount of reaction is developed or acts by the bat on the ball. That means force exerted by bat on the ball is in leftward direction. As this force which acts on the bat is exerted by ball, means body 1 on body 2, that means bat. Similarly, what force we are getting here is F21, meaning is what? Force exerted by body 2 on body 1, that means force exerted by bat on the ball. Now as these forces are exerted in what time? When ball strikes with the bat, then ball remains in contact with the bat in a short interval of time. Therefore, such a force which is developed, which is a large amount of force which is developed in a short time interval, then such a force is called as impulsive force. That means F12 is impulsive force as well as F21 is also impulsive force. That means what is the meaning of impulsive force? The large force which is exerted in a short interval of time when two bodies collides with each other. Therefore, first term is impulsive force. Next one, this force acts on these bodies in a short interval of time. Product of this impulsive force and the time interval in which this force acts is called as impulse of a force. That means second term is impulse of a force. Let's write these terms one by one. See here on next page. Kinetics of particles 3, impulse, momentum, impact, it's nothing but collision between elastic bodies. First term what we discuss is impulsive force. Say number 1, impulsive force. Now this force, impulsive force means which type of force? Impulsive force is a force which is developed or exerted when two bodies collides with each other in a short interval of time. That means impulsive force, if you want to write, impulsive force is defined as what? Impulsive force is defined as a large force which is exerted in a short interval of time during collision, or during collision when such large amount of force is developed in a short interval of time, then that type of collision is called as an impact. That means impact is a particular type of collision in which when bodies collides with each other in a short interval of time when large force is exerted, then such type of collision is called as impact. That means what these forces develop is nothing but during collision, means during impact. The impulsive force is a large amount of force which is developed in a short interval of time during collision. Next term what is important is nothing but impulse of force. Now impulse of force is nothing but simple, it is product of these two terms. It is a product of impulsive force what is developed and the time interval in which this force acts. If you will assume a time interval in which this force acts is say dt or delta t, then this impulse is given by product of what? Impulsive force into the time interval in which this force acts. Say impulsive force is F into what? This time interval delta t is nothing but impulse of a force. The first one is impulsive force. Next term what we discuss is impulse of a force. Number 3, third term important what you must know here is nothing but momentum, where momentum is always a product of mass of a particular body which is in motion and its velocity. That means momentum is simple, it is given by product of mass and velocity of the body. That means this one is simple, mass into what? Velocity. Product of mass and with what velocity that particular body is moving, its velocity. Where this one is a vector quantity. Depending on velocity, we'll substitute here values. If velocity rightward, we'll substitute with positive sign. Velocity leftward, we'll substitute with minus sign. If velocity is upward, we'll substitute with positive sign. And if it is in downward direction, then it is negative. That means same sign convention what you are following in full statics as well as dynamics. Rightward positive, upward positive, leftward negative, downward negative. First term is impulsive force, second one is impulse of force, and third term what we discuss is what? Momentum. Let's see. Next part is what? Fourth term. Number 4, principle of impulse and momentum. Principle of impulse and momentum, basically a relation between impulse of a force and momentum. In principle of impulse and momentum, which is relation between impulse and momentum, and we'll get this relation, that means principle, from Newton's second law, where Newton's second law is what? F equal to mass into acceleration, where F represents resultant force acting on any body mass represents mass of body and A represents what? Acceleration. Now if we'll write this again, F equal to mass into dv by dt. Acceleration is rate of change of velocity with respect to time. Therefore what will get here? F dt equal to say m dv. Now what it represents? When force acts for a time interval say dt, then velocity of body increases by dv. Now if you want to find out that in what time interval, maybe from t1 to t2, what are the change in velocities? If we integrate this equation, then what will get? Integral of f dt equal to integral of m dv. Say when time is t1, velocity of that particular mass is v1. When time is t2, velocity is say v2. Now if you integrate, what will get here? F integral of dt is t, lower limit is t1, upper limit is t2 equal to integral of dv is v and mass remains constant, velocity varies from v1 to v2. That means F, this one upper limit minus lower limit means t2 minus t1 equal to m, what will get here? v2 minus v1, upper limit minus lower limit. That means what you are getting on this left side is F into t2 minus t1 is the time interval in which force acts, equal to, I'll write this one as mv2 minus this one as mv1. As we have discussed, F into delta t represents impulse of a force, mass into velocity is momentum. Now what you are getting? M into v2. v2 is a final velocity of that mass. Therefore m into v2 is called as final momentum. M into v1 is initial momentum. F into delta t is impulse of a force. Therefore what will get this relation as what? Impulse equal to mv2 means final momentum and mv1 is initial momentum, which is relation between impulse and momentum. Therefore this principle is called as principle of impulse and momentum. So impulse is always given by what? Final momentum minus initial momentum. This may be written as what? Maybe this is called as what? Final minus initial, means what? Change in momentum. Change in momentum is nothing but impulse of a force I. That means in short, if you want to write, I means impulse equal to what? Change in momentum. This one is our fourth point, principle of impulse and momentum. Next one, from this principle of impulse and momentum, what will get here? Number 5, law of conservation of momentum. In law of conservation of momentum, from where we will get law of conservation of momentum? So that one will get from principle of impulse and momentum. As you know, impulse equal to what? A change in momentum. Impulse is change in momentum. That means this one is what? mv2 minus mv1 or delta mv. Change in momentum is what? Impulse. Now when two bodies strikes with each other or collides with each other, or when impact takes place, impulsive forces are developed, where magnitude of impulsive forces which are developed are same and directions of impulsive forces are opposite. As you already discussed, just see again. When ball strikes with bat, force is exerted by ball on the bat, say F12. Force is exerted by bat on the ball, F21, and these forces are developed in short interval of time. That means in this case, what forces are developed? These are developed when this ball is in contact with the bat and ball remains in contact with the bat in a short interval of time. Therefore during impact, what forces are developed are a sort of reaction. Therefore magnitude of these forces are same, F12 equal to F21. As these forces are developed in a short interval of time, therefore what impulse will get due to force F12 is F12 into dt, rightward you can say positive. Next one F21 into delta t, which one is in leftward direction, that means it is negative. That means during impact, if we add these impulses of the force or sum of impulses during impact is 0, because magnitude of forces are same and directions are opposite. As sum of impulses is 0, that means I term is 0 on left hand side. So what will get here? Change in momentum equal to 0. Therefore what we have written, I is delta mv during impact, sum of impulses is 0. That means I equal to 0, which is equal to what? Delta mv. Delta mv is what? This is change in momentum. That means change in momentum during impact is what? 0. As a change in momentum, what you are getting finally, change in momentum equal to 0. Change is what? Final momentum minus initial momentum. That means final momentum minus initial momentum equal to 0. Final momentum minus initial momentum, final momentum minus initial momentum 0. That means can you say final momentum equal to initial momentum or initial momentum equal to final momentum. That means here if I write law of conservation of momentum, so it is finally what? Initial momentum equal to what will get here? Final momentum. Now this one is possible during impact. Now in impact always two bodies are involved. Say first body is of mass m1, second body is of mass m2. Body 1 moves with some velocity v1, body 2 moves with some velocity v2. So initial momentum is nothing but mass into velocity of each body. So for first body, initial momentum is written as m1 v1 plus for second body it is written as m2 v2, which is equal to final momentum is after impact. What is the momentum? Now after impact velocities of bodies changes. Therefore here final momentum of first body will write m1 v1 dash, and for second body I will write this one as m2 v2 dash, where v1 dash and v2 dash are velocities of bodies 1 and 2 just after impact. v1 and v2, these are velocities of bodies just before impact. m1 and m2 are what? Masses of bodies 1 and 2 which are involved in impact. Therefore here these terms represents what? m1 and m2, masses of bodies 1 and 2 respectively. v1 and v2 represents what? Velocities of bodies 1 and 2 just before impact. v1 dash and v2 dash represent velocities of bodies 1 and 2 just after impact. In law of conservation of momentum, finally what we are getting? m1 v1 plus m2 v2 equal to m1 v1 dash plus m2 v2 dash, where m1 and m2 represent masses of bodies 1 and 2 respectively. v1 and v2 represents velocities of bodies 1 and 2 just before impact. v1 dash and v2 dash represents what? Velocities of bodies 1 and 2 just after impact. Next term again we will discuss now. Next important term is coefficient of restitution. Coefficient of restitution and is represented by E. Now coefficient of restitution means what? For that one, just see here, if say this one is one body of some mass m1, say body 1, its mass is m1, and this body moves in a rightward direction with velocity v1. That means first body 1 of mass m1 moves in rightward direction with some velocity v1. Similarly, there is one more body, say body 2 of mass m2, which one again moves in rightward direction, say v2. That means both the bodies are moving in same direction. And if I'll say body 1 strikes with body 2, if body 1 strikes with body 2, then velocity of body 1 must be greater than velocity of body 2. Then only body 1 strikes with body 2, or you can say collision takes place or impact takes place. That means for this collision, velocity of body 1 must be greater than velocity of body 2. Then body 1 strikes with body 2. As velocity of body 1 is greater, and as time passes, say initially they are at some particular distance, as time passes, the distance between the two bodies gradually decreases, and finally body 1 strikes with body 2. That means what you can say, body 1 approaches towards body 2 before impact. Therefore, this difference in velocity, if we take here v1 minus v2, will get positive value because v1 is greater, and this velocity is called as velocity of approach. Is called as velocity of approach. So before impact, difference between the velocities of these two bodies, v1 minus v2, is velocity of approach, because body 1 approaches towards body 2 as v1 is greater than v2. When body 1 approaches and finally say body 1 strikes with body 2, say this one is the impact. Once body 1 strikes with body 2, what happens? This body 1 moves with some velocity after impact, say v1 dash. Just after impact, velocity of body 1 v1 dash, and just after impact, velocity of body 2 is what? v2 dash. v1 dash and v2 dash represents velocities of bodies 1 and 2 just after impact. That means after impact, as bodies separates with different velocity, definitely velocity of this body 2 must be greater than velocity of body 1. Then only you can say separation is possible. Otherwise bodies can't separate from each other. If, for example, if you assume v1 dash is greater and v2 dash is less, then separation is not possible. What happens? Body 1 pushes body 2 in rightward direction as its velocity is greater. If velocity of body 1 is less and velocity of body 2 is greater, then only separation is possible. Therefore, what difference in velocity you will get between v2 dash and v1 dash, this difference is positive and is called as what? Velocity of separation, and is called as velocity of separation. Now depending on these two bodies which are given, that maybe you can say glass marble, this one is also glass marble, maybe this one is plastic, this one is plastic, this may be plastic and maybe glass marble, maybe plastic and maybe wood. Any pair of material, if you take any pair of material during collision, whatever be the two bodies collides with each other, or any particular type of pair, any two materials are involved or materials may be same, this ratio of velocity of separation to the velocity of approach always remains constant and is called as coefficient of restitution. That means how we will define this term coefficient of restitution? The coefficient of restitution is defined as the ratio of velocity of separation to the velocity of approach. That means if we'll write this coefficient of restitution as E equal to, so what will get here? Velocity of separation to the velocity of approach. Let's continue on next page. Velocity of separation, you know velocity of separation is v2 dash minus v1 dash. Velocity of approach is v1 minus v2. We'll substitute these values here. E equal to velocity of separation is v2 dash minus v1 dash, and velocity of approach is v1 minus v2. This one may be written as, if I take minus sign common from denominator, so it becomes v2 dash minus v1 dash upon v2 minus v1. If we write like this, then this recalling formula becomes easy. The coefficient of restitution is given by minus of v2 dash minus v1 dash upon v2 minus v1. That means first velocity always for second body. Second, what we are subtracting is velocity of first body. And in numerator, velocities of bodies after impact. In denominator, velocities of bodies before impact, and complete value is with minus sign. Now, depending on value of this E, coefficient of restitution, E value varies from 0 to 1. Range of coefficient of restitution is 0 to 1. Depending on what value of E is given, accordingly, these collision between the bodies or impact, they are divided in 3 categories. Therefore, we'll write this one as what? Point number 7. Say from this one what we'll get? Types of impacts. In that one, number 1, that means first case you can say A, if E equal to 1, that means if coefficient of restitution equal to 1, then the impact is called as perfectly elastic impact. So maybe in some problem E value is not given as 1, and in wording may be written coefficient of restitution is not 1. What is given? When two bodies collides with each other, assuming say impact is perfectly elastic. Whenever this wording is given, E is not given, then what we'll do? We'll take E equal to 1 for perfectly elastic impact, because when E equal to 1, then the impact is called as perfectly elastic impact. Then value of E, maybe you can say E what you are getting is less than 1 and is greater than 0. Any value between 0 and 1, greater than 0 and less than 1. If such value is given, then the impact is called as semi-elastic impact. Then it is called as semi-elastic impact. Again, what is possible? Third case you can say, see, if E equal to 0. If E equal to 0, this one is also possible. When E equal to 1, impact is perfectly elastic impact. E is greater than 0, less than 1, impact is called as semi-elastic impact. If E equal to 0, then the impact is called as perfectly plastic impact. That means from a range of values of E, you will get some 3 different types of impacts. When E equal to 0, impact is perfectly plastic. Now if we will substitute value of E as 0 in our formula of E is what? V2 dash minus V1 dash upon V2 minus V1 and which is equal to 0. What we are writing, this equation is for perfectly plastic impact. So for perfectly plastic impact, E equal to 0, that is minus of V2 dash minus V1 dash upon V2 minus V1, this term is 0. If we multiply here denominator to 0, so what will get on right hand side is what? 0. Therefore, can you say V2 dash minus V1 dash equal to 0. Therefore, V2 dash equal to V1 dash. Now what it represents? V2 dash means velocity of body 2 just after impact. V1 dash represent velocity of body 1 just after impact. That means V2 dash equal to V1 dash. That means velocities of bodies 1 and 2 after impact are same. Therefore, this velocity may be written as V dash and called as what? As both the velocities are same after impact, it is called as common velocity after impact. Common velocity after impact. Is it possible to find out this magnitude of this velocity V dash, or you can say V1 dash or V2 dash, that means common velocity after impact? So you know law of conservation of momentum. Law of conservation of momentum is what? M1 V1 plus M2 V2 equal to M1 V1 dash plus M2 V2 dash. As you know, V1 dash and V2 dash are same. That means I will write this one as what? V dash common, because V1 dash and V2 dash is having same magnitude. That means M1 V1 plus M2 V2 equal to M1 plus M2 into V dash. That means this V dash common velocity is given by what? M1 V1 plus M2 V2 upon M1 plus M2. Use of this equation is while solving problem. If impact is given as a perfectly plastic impact, directly we will use this V dash as what? Common velocity to find out velocity of both the bodies just after impact. Now once we will get this coefficient of restitution, and from that one types of impact we are getting, right? One more again, some types of impact you will get depending on direction of velocities. What you are getting now, three type: perfectly elastic, perfectly plastic and semi-elastic impact from values of coefficient of restitution. Similarly, from direction of velocities also we will get some types of impact. Therefore, next point is what now? Say point number 8. Again I will write here types of impacts, but these types depends on what? Their velocities, directions of velocities. For example, say this one is A. Now this one is say one body, this one is body 1. Next body I will represent here. During impact, body 2 is in contact with body 1. Say body 1 and body 2. Now important point is what here? When two circular bodies are in contact with each other, first we will identify contact point. Contact point is this point where two bodies are in contact. For any circular body, if you draw normal to the circle at any point on its circumference, then normal to the contact surface here or normal to the circle at any point always passes through its center. Say this is center of body 1, center of body 2. If I draw a line which is normal to the contact surfaces during impact, such line is called as what? Line of impact. This line is line of impact. That means how we will define this term? New term you can say line of impact, and this one you have to identify while solving problem. Line of impact is a line which is normal to the contact surfaces during impact. Now as line of impact is a line which is normal to the contact surfaces, now I represented bodies like this, therefore horizontal line of impact is possible. That line of impact may be vertical possible, line of impact may be inclined possible. That depends on what? How position of bodies is given during impact. Now as these are the bodies 1 and 2, if we'll assume कि body 1 moves say in rightward direction before impact, say V1, body 2 moves in leftward direction, this one is also before impact. That means two bodies are moving towards each other before impact, just before impact. Now body strikes. Then what happens? Depending on magnitude of V1 and V2 and depending on masses of the bodies, that body 1 and 2 may move in any direction. That depends on masses and initial velocity. Maybe possibility is what? If mass of body 1 is greater, mass of body 2 is less, V1 is greater, V2 is less, both the bodies may move in the rightward direction after impact. If mass of body 2 is greater and V2 is greater, then both the bodies may move in leftward direction. If masses are nearly same, you can say, or there is slight difference, then depending on velocity, possibility is what? Ki body 1 may move in leftward direction after impact, represented by V1 dash. After impact, this one becomes what? V2 dash. This one is just assumption, where V1 dash and V2 dash, any direction is possible, maybe rightward, both may be leftward. What I represented here, first body leftward, second body rightward, where V1 and V2 represents velocities of bodies 1 and 2 just before impact. V1 dash and V2 dash represents velocities of bodies just after impact. Now when velocities of bodies before and after impact are collinear with line of impact, or you can say parallel to the line of impact, or you can say along the line of impact, then such type of impact is called as what? Direct impact. Such type of impact is called as direct impact. That means how we'll define this type of impact? Direct impact means what? Direct impact is a type of impact in which velocities of bodies just before and after impact are collinear with line of impact. Then the impact is called as direct impact. If the velocities of bodies just before and after impact, if the velocities of bodies just before and after impact are collinear with line of impact, then the impact is called as direct impact. And the impact is called as direct impact. Now for such type of impact, direct impact, our law of conservation of momentum and coefficient of restitution is directly applicable. Therefore first what will get? Law of conservation of momentum, say m1 v1 plus m2 v2 equal to m1 v1 dash plus m2 v2 dash. This one is number one. And next what is we are getting here is E equal to minus of v2 dash minus v1 dash upon v2 minus v1. So both the equations are valid as it is, but condition is what? When velocities of bodies before and after impact are collinear with line of impact, then this impact is called as what? Direct impact. One more type of impact is possible depending on direction of velocity. For example, if I'll take one body like this one is say body 1. Now this body 1 is in contact with body 2 again here. That means you know how to represent line of impact. Say this is body 1, a body 2. How will represent line of impact here? Line of impact is a line which is normal to the contact surfaces. That means here if you draw normal, that one passes through what? Centers of the body. Now this one is what? This is a line of impact, right? So this line what you have drawn here is a line of impact which is normal to the contact surfaces. So this one is, I'll write as a line of impact. The line which is normal to the contact surfaces is line of impact. Now this body 1 say this one moves from the direction, this is a direction of motion, body 1 comes from this side like this with velocity v1, and this body 2 comes from different side, this one is velocity say v2, both the velocities are inclined. That means bodies are not moving in a straight horizontal or in vertical direction. Body 1 moves in inclined direction, body 2 also comes from some different side. That means now impact takes place. Now what happens? Body 1 rebounds in this direction say, and body 2 rebounds in different direction. Now what you are getting, this velocity is after impact, this velocity is also after impact, therefore v1 dash and v2 dash. Now if we will see here line of impact and velocities, can we say velocities are non-collinear with line of impact? Before and after impact, velocities of bodies are non-collinear with line of impact. Then such type of impact is called as what? This is second type is what? Indirect impact. Indirect impact. That means which type of impact is called as indirect impact? If velocities of bodies before and after impact are non-collinear with line of impact, then the impact is called as indirect impact. Then the impact is called as indirect impact. Now in indirect impact and in direct impact, what is the basic difference? In direct impact, velocities are collinear with line of impact. In indirect impact, velocities are non-collinear with line of impact. Now in this one our equations are valid, that means law of conservation of momentum and coefficient of restitution are valid, but when we will apply law of conservation of momentum and coefficient of restitution, this one as it is not valid. m1 v1 plus m2 v2 equal to m1 v1 dash plus m2 v2 dash. Directly you can't apply this equation. Here the components of velocities which are along the line of impact, that one varies as per law of conservation of momentum and coefficient of restitution. Only components which are along the line of impact, and the components which are perpendicular to the line of impact remains same after impact. That means what it means then, v1 is velocity of body 1 before impact. That means here if I'll resolve, you will get this component horizontal, this component is what? Vertical. If we'll resolve v1 just before impact, that means along the line of impact, say horizontal direction, I will write this one as what? v1 x, and this one is what? v1 y. Similarly v2 if I'll resolve along the line of impact and perpendicular to line of impact, along the line of impact what will get is v2x, and vertical component is what? v2y. Now the components which are perpendicular to the line of impact remain same after impact. That means v1 dash if I'll resolve, what component will get here? v1 dash y is same as that of v1y. This component doesn't change. Similarly this component what you are getting here is nothing but what? v2 dash y. This is equal to what? v2y. Component of velocities which are perpendicular to line of impact remains same after impact, and other component, that means v2 dash if I'll resolve, will get what? v2 dash x. v1 dash if I'll resolve in horizontal direction, what will get here? v1 dash x. That means the components of velocities which are along the line of impact, v1x, v2x, v1 dash x, v2 dash x, these components varies as per law of conservation of momentum and coefficient of restitution equation. That means now for indirect impact, if you want to write these equations, law of conservation of momentum and coefficient of restitution, these equations will get in this component form. So if we'll write here, just see Law of conservation of momentum is written as then for body 1 m1, its velocity in horizontal direction without dash. m1 v1x, again I will write m1 v1x plus for second body m2 v2x, this one is initial momentum. Final momentum is m1 v1 dash x plus m2 v2 dash x. That means you have to consider which components? Components of velocities which are along the line of impact. Coefficient of restitution equation, if you write, it is minus of. Now in numerator initially what we have written v2 dash minus v1 dash, but now it becomes what? v2 dash x minus v1 dash x upon v2x minus v1x. This one is second equation. Now using these two equations, what will get? Components of velocities just after impact in horizontal direction will get. That means solving equation 1 and 2 will find out v1 dash x and v2 dash x. But other components, which components remain same? Components of velocities perpendicular to the line of impact. Components of velocities perpendicular to the line of impact remains same after impact. That means as line of impact is horizontal, vertical component remains same. That means v1 dash y equal to v1y and v2 dash y equal to v2y. That means this one is very important, you can say, concept. One component, that means along the line of impact, components will find out using law of conservation of momentum and coefficient of restitution. The components which are perpendicular to line of impact remains same after impact, therefore that component remains as it is. Once you will get components along the line of impact, applying Pythagoras theorem will find out what? Resultant velocity of these particles just after impact. Again, next important point is what? When two bodies strikes with each other, when two bodies strikes, mass of one body is infinite as compared to other body. That means this one concept is what? Say point number 9. Collision between the two bodies where mass of one body is infinite. Can you say this one is what? Ground. And here this one is say ball. Now this ball is thrown in downward direction or dropped in downward direction, right? So this ball strikes with the ground. Now what is the mass of ball? Is negligible as compared to this one strikes with the ground, means mass of earth, or mass of earth is infinite as compared to mass of this body 1, means ball 1. Say this one is body 1 and what you are getting here, this one is what? A ground. This one will take as what? Body 2. Now when any body is thrown in downward direction with some initial velocity and through some height, you can say h or maybe h1, if you assume here, what is the velocity with which this body strikes with the ground? That means say what is the velocity, this one, and this is body 1, therefore I will write as what? v1. Velocity of body 1 just before impact. Now to find out this velocity v1, simple concept, when body is dropped, if it is 0, then almost you know ki v1 is what? Root of 2gh1. But now it is not dropped, initial velocity is not 0. That means if it is thrown with some initial velocity, so what we'll do? We will use law of conservation of energy. Now as a ball is thrown with some initial velocity u from height h1, if we will apply law of conservation of energy, say this one I will write as position 1, this one is what? Say position 2. At position 1, which energies will get? To say here important energy is kinetic energy plus potential energy at this position 1 equal to again kinetic energy and potential energy at position 2. Other energies are not involved. Now at position 1 kinetic energy, the U is given, therefore what will get here? Half mass into U square. Potential energy at position 1 is due to, you can say, its height. Always potential energy is energy possessed by any body by virtue of its height. That means this potential energy is what? mgh1. Now when this body strikes with velocity v1, that means we will get some different kinetic energy, half m v1 square, and as it strikes the ground, height becomes 0, that means kinetic energy here becomes what? 0. Now if we will cancel this term mass here, mass is same body here, that means m and m if we will cancel. Now if we will find out what is now v1 square, so we will multiply by base 2. v1 square, if you multiply by 2, so what will get here? U square, and again 2gh1. That means v1 is square root of u square plus 2gh1. This one what will get here? With what velocity body strikes the ground? In case if body is not thrown, if velocity of body u is 0, when body is dropped, if body is dropped, then this u becomes 0, therefore this velocity becomes what? Root of 2gh1. But if it is thrown, then it becomes what? Root of u square plus 2gh1. Now body 1 strikes with the ground, what happens? This body will rebound with some velocity and ground remains as it is. That means if I'll say this one is what? v1 dash, velocity of body 1 just after impact. But what about velocities of ground before and after impact? Here initially ground is at rest, after impact also ground remains at rest. That means for ground, for second body whose mass is infinite, its v2 is 0 and v2 dash is also 0. Both the velocities are 0. Where you know v1 is what? Root of 2gh1. It rebounds with some velocity. As this body rebounds with some velocity, so what happens as it moves in upward direction? Its velocity gradually decreases and finally velocity becomes 0. As here relation between v1 and h1, you know, if u is 0, v1 is root of 2gh1. Now as it moves in upward direction, velocity decreases, and where velocity becomes 0, can you say here velocity becomes 0? That means what happens here? This ball attains what? Maximum height, say what? h2. That means what relation between this v1 dash and h2 will get to? Can you say it is root of 2gh2, because here velocity becomes 0. If its velocity doesn't become 0, then root of that velocity square plus 2gh2 is possible. When velocity of ball becomes 0 at some height, that height is what? Maximum height reached by this ball just after impact. Therefore relation between v1 dash and h2 is what? v1 dash equal to root of 2gh2. Now v1 you know in terms of h1, v1 dash you know in terms of h2, but we are not considering any sign here. But when you substitute these values in equation, always you have to follow sign convention. Upward positive, downward is what? Negative. That means when you substitute value of v1, definitely will substitute with minus sign, and v1 dash if you want to substitute will write with positive sign. Is there any relation between v1 dash and v1? That is possible if you will apply coefficient of restitution between these two bodies. When these two bodies strikes, coefficient of restitution equation is what? E equal to minus of v2 dash minus v1 dash upon v2 minus v1. Just see on next page. Coefficient of restitution equation is given by v2 dash minus v1 dash upon v2 minus v1. Now here you know v2 equal to v2 dash equal to 0 as ground is at rest before and after impact. Therefore this E equal to what will get here? E equal to minus of first term 0 minus v1 dash upon is 0, what will get here? V1. That means minus minus plus again minus means minus. That means what will get? V1 dash equal to minus E V1. V1 dash equal to minus E V1. Now V1 dash, if you substitute here, V1 dash is what in terms of H2? It is root of 2G H2 equal to minus E, and V1 is in downward direction. V1 dash root of 2G H2. V1 is in downward direction, will substitute with minus sign, and it is assuming it is a drop. So what will get here? Root of 2G H1 minus root of 2G H1. That means whenever any body is a drop from some height and it rebounds some particular height, say H2, what relation will get between H1 and H2 is what? Minus minus gets cancelled. What will get here? E root of 2G H1. Here what will get? Root of 2G H2. Squaring both the side, 2G gets cancelled. What will get here? H2 equal to E square H1. That means what will get here? E square equal to H2 upon H1, or E what will get is what? H2 upon H1. See here, you may get some simple problem where what is asking problem is out of 3 terms, 1 term is unknown. E unknown, H1, H2 may be given. H2 is given, E is given, find out H1. Or H1 is known, E is known, find out what? H2. That means, for example, a ball is dropped from a height of 10 meter and it strikes the ground. To what maximum height it reach if coefficient of restitution is 0.65. That means use this relation, directly will get what? Coefficient of restitution, or maybe H1 or maybe H2. Thank you.